Hello, welcome back to the lecture series on transport layer of the internet model. In this video, we are going to learn about TCP error control mechanisms. So what is the agenda? We will be touching upon the error control, then checksum, after that acknowledgement, then retransmission, then timeout, after that out of order segments. Then I will give some example scenarios of error control mechanisms of TCP. What is error control? Concept-wise, error control is used whenever we send data from sender to receiver, and during the course of transmission through the channel or the link, few of the data bits are lost or they are corrupted. There should be some mechanism to look for the corrupted or lost data and to correct them. Checksum is a 16-bit integer that is used to check for corrupted segment of data in TCP. We have learned about the mechanism of checksum in an earlier video where we have learned about the error control mechanisms or error detection and correction techniques in general. Acknowledgement. Acknowledgement is basically used to confirm the receipt of the data segments and the control segments. Suppose we have a sender here and a receiver here. If we send a data segment, let's say data segment 1, and then the receiver should send acknowledgement of the data segment. It is basically a number which is the segment number, like it is given by a sequence number 1, and the acknowledgement should be the sequence number plus 1. So whenever this acknowledgement is received by the sender, then it understands that receiver has received the data segment with the proper sequence number. It can also happen that the sender is sending some control information to the receiver. There also the receiver must send some acknowledgement of the control information. Acknowledgement segments are not acknowledged. Like if the sender and the receiver is sending some data, suppose the sender has sent the sequence number 1 and the receiver has acknowledged this. So it writes ACK 1 plus 1. So this particular information is not acknowledged by the sender to the receiver. Retransmission. Retransmission basically occurs for data segments that are either corrupted during transmission, or they may be lost during transmission, or they may be delayed. When they are delayed, a queue is formed at the receiving end, and it is only when the queue gets cleared, the data segment is received by the receiver. So during that time, if the receiver does not send any acknowledgement for these types of data segments, then retransmission of the particular data segments which have not been acknowledged by the receiver are again retransmitted from the sending end. That is, from the sender to the receiver. Retransmission also occurs when a retransmission timer expires. We will look into this with some example scenarios. And at a time when the sender receives 3 duplicate ACKs. So there also retransmission occurs. There should not be any retransmission for the acknowledgement segments. Timeout. Retransmission timeout, or RTO, time set for all outstanding segments. There may be many segments whose acknowledgement has not been received by the sender from the receiver. Then there is a retransmission timeout where a timer is set if that timer expires, then all the outstanding segments whose acknowledgements have not been received are again resent. This value of RTO is never fixed. It is dynamic in nature. And basically it is based on round trip time. Round trip time means the data segment sent from the sender goes to the receiver and the receiver resends back the acknowledgement of the data segment. So this is known as the round trip time or RTT. And timeout basically also occurs when 3 duplicate ACKs are received by the sender. So this is known as 3 duplicate ACK rule. This is for the out of order segments. What is the meaning of out of order segments? Suppose we have data segment 1, 2, 3 going from the sender to the receiver, and the receiver has acknowledged 2. That means 2 plus 1. It has acknowledged x plus 1. Here x is 2. But it has not acknowledged 1. So this one will be an out of order segment. We will look into this 3 duplicate ACK rule shortly. Out of order segments, these are basically stored in the TCP buffer. And later on they are sent to process in the order. This process means the particular server process for which the data has been sent from the client process. Let us look at some example scenarios. This is for the normal operation. We have the client here and we have the server here. Let us understand their timing diagram. Suppose the client has sent a data segment having the sequence number from 1201 to 1400. And it sends the acknowledgement 4001. This is the acknowledgement of the previous data segment that it has received from the server. Now this client sends this data segment to the server, and the server again resends the acknowledgement. So that means it has received all the segments. That is the reason it has sent the acknowledgement 1401. It should be 1400 plus 1. So it is 1401. And it is sending in return the data bytes from 4001 to 5000. So this is the sequence number that is being sent from the server end to the client end. Now after 500 milliseconds, client will send the acknowledgement packet back to the server. This acknowledgement packet will be numbered 5001, meaning that it has received the data packet 5000 from the server. The server again then sends the next chunk of data bytes like 5001 to 6000 with the acknowledgement 1401. This 1401 means it has already acknowledged the data segment 1400 from the client. Again, it can send sequence numbers from 6001 to 7000 with the acknowledgement again 1401. After a certain interval of time, let's say 500 milliseconds, the client can send the acknowledgement indicating the acknowledgement number is 7001, meaning that it has already received the chunk of data of the server till 7000. So this is the normal operation. Let us now look into a scenario where we have a lost segment. As before, we have a client here. This client here basically is the sender. And we have a receiver here. Let's say this is the server. Here, the client is sending sequence number 501 to 600 with the acknowledgement X. This acknowledgement X means it has already received some data from the receiver and it is acknowledging it. So it has most probably received data X minus 1. At the receiving end, it will create a buffer and it will store the data. Next, the client can send the sequence number 601 to 700 with acknowledgement X to the receiver. The receiver will create again the second buffer to store the data segment. The receiver then sends acknowledgement 701, indicating that it has received properly data byte till 700 sequence number. Next, the client or the sender sends sequence number 701 to 800 with acknowledgement X. But this data segment is lost somewhere and it has not reached the server end. Then it is sending the sequence numbers from 801 to 900 with acknowledgement X. It has reached the server. So what the server will do, the server has already kept 1, 2, 3, 1, 2, and the third it has not received. So there will be a gap here and it will keep the out of order segment from 801 to 900 here. And it will again send acknowledgement 701 indicating that it has not received the data bytes till 900. So after this RTO, the client or the sender can again resend this sequence number 701 to 800 with acknowledgement X. So this is the example scenario for lost segment. The server in return can send the acknowledgement with number 901 indicating that it has received all the data bytes and the out of order segments are then clearly made in order segments with the removal of the gap. Next, we look into the example scenario of fast retransmission. As before, we have the sender side and the receiver side. Let's look at the timing diagram. Here the sender is sending sequence numbers from 101 to 200 with acknowledgement X. The receiver creates a buffer for this segment. The sender again sends 201 to 300 with acknowledgement X. The receiver creates the second buffer and sends the acknowledgement with 301 indicating that it has received properly all the bytes till 300. The sender then sends the sequence number 301 to 400 and it is lost. It then sends sequence number 401 to 500. It reaches the receiver. Receiver will keep it as it is like. So it will again send with acknowledgement 301 because it has not received 301. And this will be the out of order segment with a gap. The sender will again send 501 and to 600. The receiver keeps on increasing the out of order segments because it has not received the third chunk of data as yet. It will again send acknowledgement 301 indicating that it has not received that particular segment. The sender will again send the next chunk of data 601 to 700 with acknowledgement X and the receiver is placing it as the out of order segment. So this is the third out of order segment. The receiver then again sends the acknowledgement with 301. So here the sender has received 3 acknowledgements. So these are the 3 duplicate acknowledgements with the same acknowledgement number 301. Once it receives this, it will resend the data chunk of 301 to 400 with acknowledgement number X. At this point of time, if the receiver receives it properly, then it will keep it in the proper order and it will remove the out of order segments and then it will send the acknowledgement 701. So this is the fast retransmission scenario. To summarize, in this video, we have learned about the error control mechanisms at the TCP or the transport layer. We have seen how checksum is used. It is a 16-bit integer that is appended with the data to indicate whether the data bits that are obtained at the receiver are erroneous or not. If they are erroneous, the data bits are simply discarded. Then we have learned how acknowledgement is used and when it is used to control the error. Then we have looked into retransmission, after that timeout, then how to handle the out of order segments. And we have looked into 3 example scenarios. One is for the normal operation. The second one is for the lost segment. And the third one is for fast retransmission. Thank you.